Swayam Prabha. Digital India. Educated India.
So, welcome to the second part of the Fusion 360 software demonstration. I have introduced the software to you in the first part of this. This is the final product here. So, let us do the rendering part. So, here I will perform rendering for this laptop table here. So, I will choose the environment here. The environment is rendering. Render is selected here, and here is the rendering environment. The background you are looking at here right now is an imported HDRI image. It is a high dynamic range image. It is very widely used in 3D modeling and when you want to make photorealistic renders. So, one thing you can notice here that we cannot distinguish between the boundaries of the screws and the links. So, we need to paint them a little. The painting of or for different textures or different materials can be done here for the rendering purpose. So, I will come to the appearance here. So, I will try to make the links in an aluminium texture. So, I will typing aluminium here, it is showing aluminium. So, aluminum anodized rough gray blue, I am just dragging it over the link and the link is changing its appearance accordingly. So, all these links are now turned to anodized rough gray. Now, the screws as well we need to change. For that, I am just putting black here. So, for black I will just try to put, so for black I will like to pick here coating here, black oxide coating on the screws, 1, 2, 3 screws on this side and similarly 3 screws on the other side. Now, we can also change the appearance for this top. This is the sheet metal component. For this, I can just put some texture over it. I can put some paint over it. I can put some picture over it, and accordingly, we can work on it. So, I will go for matte finish first. For what kind of matte finish is required? Plastic matte finish. Different colors are there, yellow, white, gray and so on. I will make it leather matte finish. Leather matte finish. Sometimes the properties are not available. We can also download this. So, this section, like see, this is a download available, download options available. See, we can, when we click here, it is being downloaded to the system. So, I know it's downloaded and I am applying it to the sheet. Now, this is a nice matte finish. Closing the window for appearance. We can also change the physical material, but in rendering we need not to do so. Physical materials are more important in simulation environment where we need the physical properties of a material like steel, aluminium, inconel and so. So, we can change the scene settings here. We select the scene setting environment here. Here we can change the background from environment or solid color. Here in solid color we can pick any color that we like. So, in this case I will pick environment setting and we can try to pick different environments here. So, environment library is here. You can pick wooden launch, that is already selected here. So, let me change it to grid light. we can drag. Now it has changed the background in that way. This is a virtual room with grid lights. Now back to settings. We can position the environment by which we can control the shadow effects here. Then we can change the ground scale here. Okay, let me pick some value 0.7, and the angle can also be selected for rotation. Angle for the rotation here, we can change it here. In that we can change the reflections of the component that we have made. See if it's look good. I am just trying to, okay, I am also changing the brightness manually to see. We don't need to be overexposed. Sometimes overexposed things doesn't seem very elegant. So this one seems okay. Other options can be ground plane, ground planes, some other settings can be the ground settings, and camera. The camera can be put at different places. The focal length for the camera can be changed. We can change orthographic or perspective. In orthographic, it gives 90-degree angles. In perspective view actually gives a sense of depth and importance of time. The depth of field can also be selected. But if we select depth of field, it is important to understand that the design in the background has to be selected properly. So I am ignoring depth of field right now. So we can change the focal length of the camera. Okay, this looks okay. Close the window. So similarly, we can do many changes. So we can pick this command, decal command here as well, for putting images, for inserting images, or like a 3D geometry or so. So I am importing the image from the computer. Okay, let me pick this talk. The image can be put here. Now it is put here. I am rotating it to make it vertical proper. So placing it at this center, almost center. We can scale up the image when we need. So I am scaling it up to the whole area. So already the setup is made. Scene settings, decal appearance is done. Now in texture control, texture map control, we can select the lighting conditions for the individual objects, like for the links, for the tabletop. We can select projection type planar, or spherical. I will go for automatic in this case. Display mode, appearance, okay. So now we have options for rendering. We can run a render here. So we can run the render on our desktop computer, that is the local computer itself, or we can also use the cloud rendering facility. For the cloud rendering, we need to use our credits. There are daily credits which are available for this kind of rendering, that is for photorealistic rendering. It needs 1 credit here, you can see. In this case, we will select a render quality here, and render queue times depends upon the job. The jobs, those are there on the server. So we can select different sizes here, like 4 into 6 inch, 5 into 7 inch, and we can select different PPI, 300 PPI, 300 PPI. So when we render it, it will use 2 grids on our rendering is happening. It might take a while for rendering. So we can also access the previous rendering from the rendering history wall here. A couple of renderings were done before, so we can also see them again. See, this was one of the rendering options where we use the texture surface, and it is also the room setting here. So, rendering is still going on, it will take some time. Again it needs around 10 minutes. Okay, I will just wait for the rendering and come back again. Okay, now the rendering is completed. Let us look at it. This is the final rendering output. It looks cool, I believe. We can see this small little top dog. You can choose anything that you like. We can download the image as JPG or PNG depending upon what kind of format you need. If you need no background in the image, you can save it as a PNG. In JPG it will have the background as well. So, it is being saved as JPG here. Post processing is also possible here. In post processing, the exposure, light inclination can also be changed here. The saturation can also be changed, a little higher saturation, the color correction. These all things come with practice. You can also select automatic, which are visible, and you can also keep practicing to find the final JPG that's to be saved. JPG or PNG or the other format that you would like to save here. So, this is completed. So, we can see it here, it is opening. Yes, this is the final output. So, we need not to depend upon the rendering itself, we can also change the appearance in post processor here. So, JPG or JPEG or PNG. So, again let me try to save it as PNG with transparent background. We have PNG and TIFF options here. And the final one, if you need to have 360 render small video with multiple views of your product or so, you can select render as turntable here with the options for 6 frames per second, 636 frames per second. You can change the quality of your final video. 36 frames, we do not have as many credits here. For 36 frames, you exceeded 16 cloud credits. You need not more cloud credits here. So, for 6 frames, yes, 4 credits are available that can be used here. So, we can select render. It might take a while to actually do 360-degree render. So, I am closing this video here. This was about the use of Fusion 360 software. We have made drawings like similar to what we did in SolidWorks, but the only thing is that this is a free version software, completely free version software, and rendering is also very easy to do. We had seen the differences between the two kinds of the softwares, that is cloud based or the free version. Here I will try to cover 3D printing. I will just import a component that is scanned, reverse engineered. We will try to see what are the concerns or what are the settings that we do while 3D printing this software. We have discussed the 3D printing using CUDA in the last lecture in the laboratory demonstration on rapid prototyping. This Fusion 360 has some other options than what we discussed here regarding the support structure, how do we put different supports, how do we define, how do we optimize the support structure, and how do we optimize the orientation. Those things we will discuss in this. So, this is the interface of the software. So, let me check out some features of Fusion 360 here to use or repair our 3D file for advanced 3D printing. So, usually Fusion 360 is used for prototyping applications. So, we will start to import the file, then repair the file if some errors are there in the reverse engineering in the scan component. So, to import the file, we will select open and open for my computer. So, I will try to import my component. So, beauty of 3D printing here is that we cannot, it is not limited to the design that we make. It can print almost everything. It might not produce completely precise outputs, but any shape that you can think of, while making it different components and joining them, and sometimes in a single go that those can be printed. So, most of the 3D printing supports STL file as we have discussed. So, other softwares also they like OBJ, 3MF, and so STL file, as you know now, is a combination of the multiple files and multiple triangular mesh. Now, this is the component that is imported here. This is a propeller, this was broken somehow and it is scanned to be 3D printed again. So, this is a 3D image scan. With traditional manufacturing processes, it is very difficult to create objects or scan. So, we have multiple limitations in doing that as well. Another reason to use STL file is that it is very simple to make. So, this is mesh body here. And nowadays we have multiple formats like OBJ and 3MF. OBJ is a detailed version, 3MF is more popular. It is a compressed version of OBJ which only provides you the information for 3D printing exclusively. Now, here is an add-on function where we have mesh mixture. Mesh mixture is a tool that is used to prepare the 3D file, to manipulate and to prepare the file for actual 3D printing. So, I am working here in tools environment. I just said that 3D printing can be used to produce many or almost everything, but it shouldn't be considered as a kind of a magical software or magical technique that can produce anything, because also it has to have supports for different components which are overhung, which kind of a cantilever system is there. It has to take care of so many things there. So, when we have to go for higher accuracy or different applications, other 3D printing technologies like SLS and SLA, so many technologies are there, but here I am more concentrating on FDM again, that is fused deposition modeling, in which filament is used. So, we have so many options here: mesh mixer, print studio, preform, repeater host, but I will pick mesh mixer here. Mesh mixture is an integrated component that is provided by Fusion 360. I am choosing mesh mixture here. So, opening there, it is opening the part in mesh mixture now. Repeater is also one of the softwares that we discussed in the laboratory demonstration. I will guide you through various steps in mesh mixture to repair this component. See, mesh mixture is opening. It takes some time for the components to open. The component is too big here. It is around 2 meters by 1 meter by 1 meter or so. So, it will take some time. The file size is big. And also, I am now running on my local desktop computer itself. So, it is opening mesh mixture update. So, let it take its time to open. Unlike Autodesk Fusion 360, mesh mixture is a resource intensive software. So, we have our file here. We can select our 3D printing environment here. So, we have many options here available here. It will try to emulate the similar environment for different kinds of the printers, those are available here. So, we have already selected Ultimaker original here. So, it will just simulate the one environment according to this Ultimaker. Ultimaker is one of the printers providing company, and it is one of the very broadly used. So, Ultimaker original, it has its own work volume or work envelope in which this component can be printed. So, here we have the geometry. So, this is a scanned geometry. There are certain defects you can also see here, the small defects are there. So, these defects are to be repaired, these will not be printed in the way it is scanned. So, these might be the defects in the scan, or these might be the defects in the component itself. So, we have certain options here like import, then mesh mixer, then we can edit. I am not going to discuss all of them, it is not even possible to discuss all of them in this 40 minutes lecture. So, only necessary options I will just show you. In max mixture we have certain shapes that can be created, and we can select, we can also stamping at all is not required now. So, it is for different engineering applications. So, analyze is the kind of the mesh that we create. See what is now here happening. This is our 3D printer envelope, the small cube at the bottom. This is a 3D printing envelope, and this is the object. Object is of the order of 2 meters or so. The 3D printing envelope is smaller. So, we have to first fit this object into envelope. We need to scale down the model. So, according to our print volume, it is to be scaled down. For that, I will come to units and dimensions. See, the dimensions here are around 2.6 meters by 1.4 meters by 2.5 meters. It is too big. So, let me try to change these dimensions here, say 2685. If I change dimensions on of any of the one axis here, it will fit other dimensions accordingly. So, x axis now is 100, other are fitted accordingly. So, it has now come inside our work envelope. We can make it a little larger. Also, the grid size is 10. I can say done. So, according to print volume, it is now here. So, either I can even make it a little smaller. We can also change the grid size here. The grid size is our, the grid size I am making it 20 here, and let me make it a little larger, 150. Now it looks okay. Okay. Now, as you can see, if this part has so many overhangs, it is not very suggestible to print all the overhangs, but still we need to see the different positions, different orientations for this object. For before that, let me try to see what are the various defects in this object, what are various holes, errors are there. So, it is showing these many small holes and voids, those are there. So, these are to be repaired. I will just select it, repair all. Okay, smooth fill, I will just fill them, then auto repair all. So, it has around 69 defects, exactly 69 defects it is showing. It is repairing those defects. So, if we define the component by our own, these defects would not come. So, this is important when we do reverse engineering to repair the defects or the voids, those are there. These are the small meshes or small group of the nodes which are not selected properly while scanning. So, mesh size is also important to be selected here. If we pick very dense mesh, so it takes some time, more time to print actually. So, if the mesh is selected a little broader, it will take lesser time, but the quality also has to be there depending on the accuracy that is required, depending on the surface finish, the mesh has to be selected. Also, one of the advantages here is with Autodesk mesh mixer that it is freely available with Fusion 360 software. So, it is available here. So, in SolidWorks we have to generate the STL file and edit it separately, but this is available with the free version. So, this is the produced object with the defects almost covered. Now, there are most important factors to be considered in any FDM print. One is what is the orientation of the part. Second is your support structure. The orientation and support as we have discussed earlier are two defining parameters for the product to be produced. So, for orientation I can see the automatic orientation that is tries to produce. So, let me see the layout and packing. The packing can be put in here. Okay. So, the software automatically pack your file while using minimum area. So, it has taken the component to the corner. I will select accept here. So, now we have secured our part successfully to the bed. In FDM 3D printing, the adhesion of your 3D printed part with the bed is very important to be considered. In the repeater section, we have seen the brim and the raft part, that how do we put our component on the bed and what we do, we select raft or brim. You can see here, this is a very fine boundary which is placed over the print bed, and this boundary, this small or this very small thickness, this wouldn't have strength to stay on the bed. So, it might pop off. So, we need to consider all of these conditions like brim or raft, what is to be put in here. So, one of the interesting things here is the orientation. The orientation can be selected with experience, and if you are not very experienced, we can select the automatic options here. We can optimize the orientation. So, let me select the orientation. So, it is analyzing. It will analyze all the options for orientations. Those could be done. So, see, it is analyzing 2692, around 2700 options. So, each and every possible option is being seen. It will enhance the time or accuracy, but sometimes this automatic optimization is not even okay. We can see, we will just see whether it selects it proper or not. It is analyzing all the options here. See, here we have the part. So, it has placed the part on its fins. So, overall angle is also to be selected now. Now, in orientation we can also select the overall angle. See, the orientation, it is showing the component out of the print volume. Overall angle has to be more than 45 degrees. I will select it 60 degrees here. I will just fit to the print volume. If I do not select it to print the print volume, it will make it keep the part outside the print volume. So, we are not constrained with traditional manufacturing processes here like CNC, milling or turning. We can provide complex geometries, we can have freedom to design. Only condition is that we need to provide different supports. So, this analyzing might take some time. I will just let this happen and come back again. So, now it is selected, and while putting it back in the volume, it has adjusted this orientation again. So, this is orientation that is set by the system, fit to print volume. So, it is pretty symmetric in x and y directions, but if the print or the model has unsymmetric geometries, so this option will be greatly useful to have a successful print. Like for instance, the small model of animals or humans or some biomedical human ligaments or so. Now, the print is pretty stable right now. So, I will see overhangs now. Okay, this is the overhung portion. Now, what is showing the red portion is that is the overhung portion where support is required. So, this can be handled definitely by providing support. Support structure is having small geometries. It helps us to keep the print or the overhung portion of the print at its proper place. So, let me try to optimize the support here. In our support generator, certain options we have maximum angle of 61 degree, post diameter is the diameter of our support. So diameter of the pillars of the support is also to be selected to support it properly, and also it has to be as far as possible minimum. So because supports are to be removed. And a tip diameter, tip is the portion that would be connected, that would be finally in contact with our print. So the tip, if it is put smaller, it will be easy to remove, it will leave less impressions on the print or on the model. The tip die is 0.5 mm, it is okay. So here we go, advanced support system. In the advanced support settings, we have optimization, allow top connections, 50% is okay. Okay. Now I will generate supports. It is now generating the supports. You will see the support will be created just like a tree. 555 nodes are being created. Okay, now it has produced the supports here. You can see the supports are ready. You can see here, advantage of using mesh mixer is that we can provide ergonomic support structure to our 3D printed file. One of the issues that is to be considered here, the supports are very easily removable here. So this is one of the issues that can be taken care of. So because the tip die here is 0.5 mm, 0.5 mm that can be easily removed here. So these supports would assure that the print would not fail. So this looks okay. So it is very much similar to the tree modeling and how the tree works. So I will select done, and this is almost done. There are so many options that those could be discussed here, but in this small lecture I am just trying to discuss the support structure and small repairing part here only. So we can do slicing here. The slicing can be done here in the mesh mixer itself, or we can export it to Repetier or different platforms. Then slicing we have already discussed. I am saving the component or the product into an STL file. Okay, propeller, and it is done. Now our saving would also take some time. So this is a small demonstration on using the scanned components, the scanned component and scanned product, and trying to do some repair and putting supports. There are so many things that can be done before 3D printing. That is, infill is there, then the brim or raft supports, those are to be put, then slicing time, then the movement of the extruder, that also can be controlled, the filament dia that is to be selected depending on the material that is being selected. Those things were discussed in the previous lecture. I will just quickly go through the making of one of the components. This was actually the reverse engineering. We imported a component and tried to repair and print. Now I will try to make a CAD model. How do we just make the component and try to print that or set the parameter right for 3D printing. Now that part is here. So I am going to make this hinge here now. This is a hinge. You can see this is the hinge, this component 1 and the second component is also there, and this has to be assembled. It is to be printed in this way. They printed in a way so that the hinge, there is one connector in the hinge. There is one connector here, and this is one part that is, see, this is one connector, the other part of the hinge is held like this. So if I print them separately, I could not put this here. This is not a separate pin. This is the part of the component. So it has to be printed in a one go. So how do we do that? We put some tolerances here, and we have to print them in as a single component. How do we do that? So, for that I will just make a model for this. For making this model, I have gone through the drawing already. I will just run the history for them immediately or very fast. So, these were the selected. I am running it very fast. You can make this component if you would like to. So, this one component is made, and we have to copy and paste. So, this one sketch is made. I am now trying to now copy, Control C and Control V, copy and paste. Oh, this is a second component that is being pasted here. So, this is being done here. These are two components. You can see this, the joint is made, the assembly is made, everything is done as we now this is joined here. The pivot option, pivoting is being done, and we are going to rotate this. Now, the important point, or the only important point which I like to discuss in this is how to save the component, both the components as one body. That is very important to do. See what we can do. So, this is a nice 3D component it is produced. Now, what we generally do, we save the components separately, hinge 1 and hinge 2, and I am going to import this in my repertoire environment. Now, we need to 3D print this body that is produced. So, last time we sent it to the next mixture. Now, this time I will send it to repertoire. First I need to do just I will do right click on the component and save it. Select component, right click on it, save as STL. See, this is what I am something as doing, that is not the correct way for this kind of component. I am saving it separately, component 1 as hinge 1. I will just name it as hinge 1, HINGE 1, and save. Okay. Similarly, the second component, and remember this is again these two are again the components, not the bodies. We can also refine the mesh, because this will become a STL file. So, small triangles are there. So, we can refine it to some extent. For simple geometry, we need not even refine this. This is too simple geometry. I am just taking binary format here. So, for professional 3D printers, we can pick the advanced options as well. I am also saving this geometry now. Now, this is being saved as hinge 2, HINGE hinge 2. Hinge 2 save. Now, the assembly is saved. Now, this is the repertoire environment. So, I will just open my file here. So, I will load my file, and one by one I have to select these files. Both of them are not possible to select in one go. One object at a time is selected. So, hinge 1 would come here. It is being loaded here. Hinge 1 is loaded. Now, importing hinge 2. Now, this has come in our repertoire environment. Now, the interesting part is, if we print them in this way, how would this movement, now the interesting part here is that if it is printed in this way, how would this part, this joint work? So, for this case, these both have to be printed in a way, this tolerances, this dimension and this dimension has a gap of 1 mm spacing is there, that will be taken care of. It has to come as a one part here. So, that is important. So, how do we do that? So, let us see. So, this is how it looks like if I import it like this only. These are now two different components. It is going to be printed separately here. So, it has come on our printer environment. So, for that purpose we have to make or select them and combine them. So, we have tolerances in between them in the joints. So, we are using combine command to just make the object as a single body now. This is single body. So, now this combined has to be saved as an STL file. It is to be saved, save one file per body, save one file per body would again save in or again save it as separate files. I have to save it as one file, saving it as one file. I will say it as hinge, simple hinge. Now again loading the body, select file and hinge. Now this is being imported here. So here we can see the file is now assembled, it is a single body. Now we can delete the unwanted files here. I am just selecting and pressing del button to delete them. So this is the file that is to be created. There are so many options that we can use here. The similar options that we have selected, that we have chosen in the previous video. We can rotate the object, we can see the orientations for them, we can choose the slicing, we can choose the filament dia. So many options can be selected here. So I am choosing QD engine again. So there are so many options. I am not trying to repeat the things that we did in the previous lecture, and these things, this health thickness etc. can be selected. So raft and brim can be selected, skirt and brim. So all these options can be selected and this component can be printed. So let me try to finish this quickly. With the parameters set, I will just put or fire my slicing, slice with CUDA engine. Now slicing is happening. So with the set parameters, the slicing software is slicing the objects, slicing this object into multiple layers of 100 micron. It was the fit parameter here. So it is showing the values. It will show 299 layers. It will take 58 minutes. And the component, the slicer we can see here, it is a similar thing. So this we can also again select here whether we to put brim or raft, what kind of adhesion we need to put here. Support has to be everywhere, speed low or high, the infill density is important to be put here. So it is also the beauty of 3D printing that with respect to the injection molding. Injection molding is generally used where high quantity is required, very high quantity is required because the dies are to be made, the dies are a little expensive. 3D printing can be hollow from inside. Injection molding, it is very difficult to produce hollow parts from inside. Here we can just select the infill density and we can opt to choose the hollow or the completely filled component. So this was a small demonstration on 3D printing. This was on demand. I have just used the two platforms, RapidTire and Mesh Mixer, which are very widely used, and these are these have taken from the Fusion 360 platform through that. So with this 3D printing rapid prototyping part of the course is over. We will meet next week where we will discuss the recent or the future technologies like virtual reality, big data, augmented reality, Internet of Things, Industry 4.0 in the overall we will discuss, and then we will conclude this course. See you next week. Thank you.